Recording? Okay. All right. Well, Boats, do you want to take it away?
Yeah,
Or,
one sec. Sorry, I just spent a lot of time trying to make Zoom work. Is there a paper?
oh yeah, there's a hack MD.
Is it in Zulip?
I posted in Zulip. I'll put it in the chat too.
Okay,
The main reason for hack MD is then I can insert it more easily into the minutes.
sounds good.
Share it, unless someone else has something they want to share.
Great. I need to have. Okay, so I'm gonna need an account to be able. I guess someone else will type, so that's fine.
I'll try to keep a typing log.
Okay, yeah,
Might
and I'm
be
now using.
important.
Yeah, I'm using like a laptop I don't normally use because I thought the Linux laptop wouldn't do Zoom, and now I like don't have unlogged into anything. It's the whole thing. So basically, so I guess I would just give an origin of how this happened. Is that someone made a PR to remove at most the limiter to our current array implementations of that's like the trait it's called like at most length 32 or whatever it's called because it's not technically necessary and we had previously just done it just to make sure that the set of impulse that stood exposes doesn't change, but we've been using the constant Eric's impulse for about a year now, more than a year actually, and they work fine. And so this was sort of just randomly assigned to me, and then I was just inclined to agree that we should just remove uh, the limiter from all of these impulse, which then raised the question: if it's good enough for std, then maybe there's a subset that's also good enough for most libraries that currently are implementing traits for arrays up to 32, or however they handle the situation with arrays. Could we make it so they could implement their traits for all arrays? And so talking with the people who've been working more closely on Const generics, uh, there is a subset that they feel is like ready to stabilize, which would cover like all the impulse and std and a lot of functionality that all the sort of basically the functionality to make arrays a first class citizen is really what it covers. Like it doesn't cover any of the sort of fancier uh, using it to like create ranged integers and things like that, but it covers these sort of like these cases like arrays and where you just have something that's abstract over like a constant. And so the two restrictions are first limiting it to only the integral primitives, which means the signed and unsigned integers, char and boolean. So um, the sort of primitive types that are just a single primitive, so not a compound type, and then also not floating point, right, or reference or anything like that. They're just a set of bits that has a defined meaning. I guess so, sort of floating points, but they don't have to deal with nan. And also, um, the sort of bigger restriction that's going to be harder to lift is that it would only allow either anything that currently could be a const expression that don't involve any inputs that are type parameters or const parameters, or just a single const parameter. So you could have um, any sort of anything you could use, like create a const right now, you can use that. And then you can also use like if your impl is parameterized by n, you can use n, but you can't do something like n times 2 or n plus n or n plus another const parameter. And you also can't do things like size of t, where t is like a type that is an input to this function. So you can't write. So there doesn't have this sort of feedback between the type system and these const expressions.
Hold on. So the idea would be that basically it's either some expression that could define a constant right now.
Yeah. So anything that anything that we allow or will ever, as we expand, like, right, I guess now we can have an if, for example, you could allow that, like you can have those kinds of statements. You can call a const function, you can do math, but it has to be, can't have any free variables in it. Like no free type variables or const variables.
I see. So it's something like this.
Yeah, exactly.
Okay.
So to clarify, based on what I'd seen written elsewhere, you can either have an existing type parameter verbatim, like in, or you can have a constant expression that can be arbitrary but can't include any generic parameter. You can't have an expression that operates on a generic parameter.
Yeah, exactly.
Okay, I want to circle back to this question.
Yeah. Yeah, because there's actually, I think that is basically Eddie says, and it makes sense to me that we can do this syntactically, but that's something we have to, probably everyone has to agree. Makes sense.
Yeah.
Yeah.
I mean, but the intuition is kind of, it can be a constant value or a const parameter.
Yeah, basically. And so it's supposed to be, we're feeding in to the system. You can feed contents into the system, or you can just have a tree where they eventually go down to an array length or something, deep inside a nested struct or something. But you can't be doing this kind of math on them as they're passing through the type system.
Yeah. Okay.
And I mean, that's it. So we would just need to have that subset under a separate feature gate, have good error messages, documentation, tests, everything, and then we can stabilize it.
There's one small other restriction, because we can't implement const generic defaults right now. So it would probably be, if a struct has a const parameter, it must not have any default type parameters.
Yes, but I think that is actually, I mean, I think we have to implement that restriction possibly, because it might not be implemented correctly right now, but like the idea of what we talked about in Zulip of having allowing them to come in any order is that the default parameters are going to have to come last regardless. So like until we allow const parameters to come before type parameters, like we just can't allow the last parameter you can have default parameters before non-default parameters, which means since that's the restriction we actually have to have, and we can't have consts have default parameters right now. So
I didn't fully understand that. So the restriction is that the default for a const parameter cannot depend on.
No, it's not to do with that. It's to do with the left to right ordering of them.
Right. So right now they're required to be in some order. Do we require constants to come last?
Yeah, currently require constants to come last. And I think we currently also still allow you to have a default type parameter before the const, but we should not, in the long term, we probably want a freeform order where constants can come in between before type parameters, but that all the defaults have to be, you cannot have any non-default to the right of a default.
And what is the thing we would be trying to prevent that? I didn't recognize the voice who was speaking, but it was cited.
I mean, I think it's things like if you have we need to be able to figure out which parameter you're filling in with that, because you could have a t, which is both a constant and a type, right? Because they're separate namespaces. And so if you have a default type parameter and then a const parameter, and you fill it in with t, and you have both a const and a type in scope, there's this ambiguity.
I see.
Presumably, this is something we could prohibit in the implementation and prevent having defaults before non-defaults. We just don't currently.
Yeah, I think that's the status quo. Yeah.
Well, given that it isn't stable, then that seems reasonable to change.
Yeah. And I think just disallowing them before, like right now, if you have a const parameter, you just can't have default type parameters. And then dealing with allowing them to be reordered and having defaults and so on can come after the MVP. I think that's enough to.
Something like that. Okay. All right. Well, I had a couple questions in the queue. Maybe we'll pop one off. I wanted to talk a bit more about characterizing the set of things that don't depend on parameters, both from an implementation perspective, maybe, but also syntax. How do we just looking for whether there's a free variable in there? Is that enough?
So it's almost enough. But here, I'm going to open the HackMD from my other laptop.
Oh, yeah.
So while we're talking about this, Eddie found an example that will be broken by lazy normalization that compiles unstable today. And so the same principle applies to it, just sort of in general. Sorry. Okay. Oh, I see it. Now I understand the interface. So and then you have trait T. And then
Yeah, okay.
so right now this compiles because in the context the const is evaluated in only the impulse that are in scope from the module, right, from this crate, which can only find the impl for trait parameterized by unit. But it should also find the T and U, and therefore find this to be ambiguous.
Yes. I was wondering about something like that. Okay.
So that already is the case, because this code will compile unstable today. So this will be there will be more const parameters, and so this kind of problem will be more pernicious by stabling const generics, but it doesn't introduce any new scenario. And the problem is already the only thing we could find that's allowed in a const context that could depend on dispatch in this way is these kinds of associated consts. And so this feels like a pretty something that we might need to have. We might need to start have lints and do a deprecation cycle, but it's not a.
Yeah, we have some other, as you said, it's unstable. I don't know. There's a sort of host of scenarios that are kind of like this that I expect as we get better have to resolve somehow.
But so it seems like For now, we can just syntactically exclude free parameters. Like just if the AST contains one, a reference to one, then disallowed.
Well, you would be able to use named constants?
Yeah.
Yeah, okay. It's not like we disallow all three identifiers, but just those that resolve to type print.
Yeah, like by free variable, I mean, yeah, when it's like, on an impl block, whatever, it's like currently an unknown type or a constant.
Yeah, I'm trying.
But we can do that based on syntax and name resolution without having to actually run the, you don't have to execute the expression to find out or anything.
Okay. So my next question, I'm going to move a little bit lower on the queue because it's a bit futuristic, but I wanted to talk a little bit about equality. So Varkor writes, I'm not sure which. We can probably allow aggregate data types, e.g. tuples of U32 and so forth. You're just saying in terms of the set of types that we accept here.
Can we do so without having integer trees?
Yeah, I thought that the reason we were excluding that was
there are some problems there, as far as I know.
Yeah, I think that was conditional on getting integer trees because Ollie suggested that it would be worth blocking const generics on the integer trees.
Can you say a bit more about integer trees?
Yeah, let me just find the MCP.
So yeah, if we're blocking on that, then I think that we could allow everything that has like the correct structural equality, right? Which is then we'd have to come to a consensus on what that means.
I think we could still avoid having that conversation yet because we would still only allow the primitive data types, but we would also allow them to be nested. We still wouldn't allow other things with structural equality, like things that derive partially
Right.
and eat. But maybe that we want to delay that anyway.
Yeah, so I guess if we do need to block on that, then I mean, there's no reason not to allow these. But I think that we need to, probably the compiler needs to decide if we need to block on that or not. There needs to be a discussion to make sure.
It's basically an implementation technique. The reason to block would be that we expect weird bugs and stuff that we're not aware of now.
Just for integers, I think we should be fine. So this is only if we want to allow tuples, because then there are padding bytes, which are a danger.
With today's code?
Yes.
Okay.
I think the main motivation to block on it was that I think Ollie's impression would be that it wasn't too difficult to implement and it would make the feature more rich for users. But maybe users don't actually care about using tuples of integers anyway, so it's not so much of a problem.
Yeah, I can definitely see people wanting strings and wanting custom type and enums and things, but I think if it's just tuples, I don't really see that being a big difference for the MVP.
One of the big uses I know people want strings for is something that won't even work until you have more complex expression manipulation, because with what we're describing and the limitations of it, even if we had strings, you couldn't invent heterogeneous lists, I believe.
But you're saying tuples would be used to make heterogeneous lists, essentially. Yeah, I'm dubious that just tuple of integer types is. I mean, I guess I'm sure it enables some hacks, but some clever stuff. Uh, okay. So, Josh, this was in regard to the discussion, your question here. That was in regard to this discussion about on parameters.
Yes, I wanted to double check on the limitations here that if you can have a generic parameter but no expression on it, or an expression that contains no generic parameters, what about a reference to a generic parameter that has an associated constant? Are you allowed to do that as long as it's not in an expression, or is that not allowed?
Yeah, that's not allowed.
Okay.
That's sort of that's one of the
is T.
yeah, because it's just it contains T and it's not just a literal like just to the const. Yeah.
That's what I was trying to find out. So it's not just that you can't use an expression, you also can't reference something via a path either.
Yeah, yeah, you can't project.
Okay. That
but
half answers my next question, I think, but I wanted to confirm it.
yeah, I think well, we don't. I mean, I think the thing about it is that the main use case, one of the big use cases for the type num stuff right now is this like crypto hash stuff where there's a hash trait and different implementations have different lengths of hash outputs, and that will not be supported by the MVP. So they will still have to.
Right.
Yeah.
So, so one big use case is hashing, like constant hashing, or
No, like crypto hash, like cryptographic hash, like the libraries that the cryptographic people implementing cryptographic hash uses. Like that library uses an interface that is abstract over all hashes, and then each implementation chooses a length. I actually don't know if there's anyone like what the use case for that abstraction is. I think that it might kind of be a bad choice, but like you could just have different hash traits for different lengths. But yeah, so like that isn't supported by the MVP because it would feature like a function that returns an array of an associated constant length, and that is not being allowed by the MVP.
I can see what the use case for having that abstract interface would be if you want to support an arbitrary hash function, but you need to know how big the length is so that you can manipulate values of that type, write them out, that kind of thing, without having to deal with variables at runtime.
Yeah, and
But
I'm being
yeah.
a bit flip. Like I've also like I've written the library that is abstract over different hashes at different lengths. So like I know it has use cases, but
I
was
don't think
saying
it's going to
that
be
I wouldn't have done
right
all the
away.
type num just to do that. But
so. Josh just asked a question about. I didn't really understand. I sort of understand the gist of the question, but not the exact wording. Maybe you want to rephrase it, Josh. But to enable prevent.
Sure. So what I'm wondering is, we are preventing people from doing math on constants. Is what we're doing going to push people towards doing type level math themselves by inventing piano numbers or similar? I don't want to end up in a scenario where we our minimum constant mechanism is useful for certain things, but people can always get the full power in a much more complicated way, and this makes them inclined to go invent complex type level number libraries, which, by the way, already exist.
right. I mean, I think that's why we were talking about the crypto hash stuff, because they do use piano number. They use type num, right?
Right.
And so we won't support those people. Like that's I think the most prominent example in the ecosystem of someone who's currently using type num who won't be able to switch to using const generics with the MVP.
Right. I think what I'm trying to ask is, does anybody feel like because we are providing some useful things you can do with constant generics, this will push people towards wanting const generics more, and then if they find they're in the subset we don't support, there will then be more usage of type level numbers. I just want to figure out if there's going to be a negative effect on the ecosystem. I don't think it's likely, but I wanted to ask.
I don't think so. But yeah, if anyone else on the team.
Yeah, I also don't think so.
Yeah.
Okay.
Yeah,
I'm satisfied.
I think the evidence is that they're already doing it,
there.
right? Because currently we give them nothing, and so they are doing it for everything. And so we're just migrating a lot, like 80% of people onto something less bad.
Yeah, I suspect that like people who can't get by with the subset, but who wouldn't have been inclined to use type num today probably still aren't inclined. Okay. Should we talk about equality, or is there other topics to bring up first? Let's talk about equality. So, I just wanted to bring up this idea because we periodically hit upon, like we've had this long unresolved notion of thinking about equality in matched expressions, thinking about equality in other contexts, and every once in a while we talk about it, and I don't know. I would like us to start moving towards a resolution at some point. I know I don't intend to block any. I don't think we should block any effort to make progress here. But since we're talking about constants, I thought it would be useful to ask if, like, kind of go over the topic again and see if where the current feeling is. Or less. Is that an issue? Yeah. Yeah, this. So I'm trying to bring it back in cache right now. Like the last time Felix and I talked about it, I think there are kind of three notions where equality kind of winds up becoming relevant. Or like there's obviously dynamic equality of when you compare things using the equals operator, which dispatches to partial EQ or EQ. And then there's sort of when you match on something, match on a constant. And then there's like R2 types equal to each other. And there's obviously these have like relationships between them. I don't know. I'm wondering if someone wants to kind of summarize the state of play. Has one actually, no. Or we can look
This is definitely out of cache for me as well. I remember thinking a lot about this a while ago, but I haven't thought about it since, so I need to refresh my memory.
Yeah. Maybe the answer is we shouldn't try to resolve this at all today. Instead, we should talk about this issue. It's too in depth. I think
it definitely shouldn't be an issue for the MVP, so it might be worth just making sure we have a long discussion about that when we're ready to move on to the next step of stabilization. Or before that.
Yeah. What about with respect to the MVP, what happens when you try to match on generic constants today? Like if I write also, maybe I'm getting the syntax wrong here or something. I don't know. I don't remember what syntax we landed on. Can I do this today? And I guess more generally, is there?
So at the moment, you can't match on any expression with a constant generic parameter in it. So I think that's because there was no discussion in like the RFC or anything like that about exactly how we should support constant generics in patterns. So I guess that's a discussion for, well, either now or later. But at the moment, it's very much safe because we're forbidding things that we're uncertain about.
So you can reference like an associated constant, but not a only of global things. Yeah, I could do something like if we had that example from above. I could match on something like this. Is that right?
I think that's right. Yeah.
So, yeah, I mean,
Okay.
I don't think that was omitted intentionally from the RFC, I mean. Well, no, associated constants also can't be referenced in patterns, according to Clayton. So,
Okay. So we're just kind of disallowing non-named constants.
yeah, I don't know why. But like, I think I assume they're sort of the same underlying issues, and so we could just treat that as one feature, right?
Yeah, I think it's fine. I'm actually happy that it's forbidden. I mean, it's less room for weird, surprising interactions that we hadn't passed. So in terms of, it doesn't seem like there's a lot of dissent on this. What, like, what are the next steps? You mentioned, I mean, we have to make sort of a stabilization report, obviously, but are there other steps that you?
So yeah, there's a compiler MCP on creating the feature, which needs to go into FCP, and then I think LCNR offered to implement it.
Okay.
And then we need to, stabilize that feature basically. So we need to have good tests and good bugs and documentation.
The test is what I was wondering about. Like when we did the async effort, a big part of it was we tried to do more systematic testing. And as I recall, we found quite a lot of surprising things.
Yeah.
The one that really stands out to me was we realized like the lifetime elision was totally wrong. I don't know if we expect anything here, but I feel like I would like some more confidence that we're actually trying to use constants in all the places you could try to use constants, and we looked at those and thought about it. Maybe that's part of the carving out of the feature, though, and maybe those tests already exist. I'm not sure.
We could definitely do with more tests. I think we've built up quite a collection now, but often are testing very weird things and not the minimum set. So.
Yeah, because I mean, we do have at least, the stood traits all exist, so that's some use at least. But like, I think at async await at this point last year, like no one was actually using async await in reality. I think so like it wasn't surprisingly found. I guess Google was using it, but
yeah, I was gonna say I think people were using it. It's just that it turns out that like production users actually often don't stress test features very much.
Yeah.
Or around
Or
weird
they
bugs.
don't realize that they're hitting a bug where they just get a
Yeah, exactly.
error and they work around it and they don't report it.
I think it would just, I guess I'm saying it would fill me with some, it would make me happy if we had like a chart with like language constructs and tests and little check marks saying that we thought about it. I'm sure it's going to work out fine. Otherwise, I think this is good. I'm really excited.
Yeah. Yeah, I mean, I think that's probably what could come up, but like, I think that we just, once we have like a clear thing to stabilize, then it just goes through the process, right? And either there are bugs or there aren't, but we find them before we.
Yeah, right. Exactly.
Yeah.
I mean, I think it's mostly going to be not so much bugs as, oh, maybe we should not include that in the.
Right. Yeah. So I think that it's just like this match thing that maybe there are expression positions in which consts could appear that we need to exclude, but haven't thought of.
I don't know what they would be. So.
Yeah.
What is this example that we can do? It's like associated constants.
So associated constants are allowed, but not if the parameter is free, like not if it's not a generic.
Yeah. Oh, I see. That's probably even if it can be resolved, right?
Yeah. Or I don't know.
Like you could have one where it says, I don't know, something on the neck to make it, I guess.
Right.
Now it's you still know exactly what this is. No, that does.
Cool. So.
Now you have to wonder. Okay. Any other comments or thoughts people want to share? I guess the only other question is, who's going to do some of this work, but I think we'll work that out on Zulip, to work it out in the sync meeting. And I know there's a lot of people in the, who've been pretty active in the compiler side on this call, and so I'm not too concerned about
that. Is there substantial overlap between the const generics minimum subset that we are proposing to try to stabilize and compile time function evaluation insofar as we should make sure that the two sets of people are talking to each other? I realize that you can't use these const generics in constant evaluation, but we did explicitly say you may either use const evaluation or a const generic parameter. It feels like the conversation ought to at least happen.
I mean, I think that they are mainly the same people.
Okay, that's all I wanted to make sure.
But also, I think it's worth pointing out that the way that they connect is that you can use anything you can const eval can now be used as an input, right, to a type, because you can use it in a const parameter position. But that's always been true for array lengths. So right, you can call a const fn to get an array length already.
Yeah, I think there are somewhat like overlapping but disjoint sets of people, not disjoint, overlapping but non-equal sets of people. I know Ali has Ollie's definitely at least a major bridge, and then I'm not sure the rest of you can speak up, but there are definitely bridges and they are involved.
Yeah, I think Ollie and Eddie are the two people who are involved with both quite heavily.
Yeah. Yeah, but it's true that a lot of this stuff, a lot of the issues surfaced through array lengths anyway. So
Yeah, it's nice in a certain sense.
cool. Any final comments, or shall we end the meeting?
I'll ask offline how I prepare a post for the LinkedIn blog.
Yeah, that's easy. The only thing I want to say is that just generally, I like this. I'm inspired by this approach. And I think we should look into where else we can apply it. Like I've been thinking about a similar thing, the idea of carving out a subset, that is, to make progress. I know it's a standard tactic in our arsenal, but sometimes we forget.
Yeah.
I think we do it for infiltrate in particular, and we've been Matthew, Jasper, myself, and a few others recently had a meeting talking about that. So I'm hoping to bring that one up too at some point. But we should look for opportunities like this in long-standing problems and see what we can do.
Yeah. There's still min specialization that exists, right?
What?
Like the min specialization feature exists. Is that if you actually look at stabilizing?
I don't know. I was thinking about that question as I spoke. I think maybe it's not quite. I'd have to go review exactly what it's implementing and so forth to be sure. But I think there certainly is one could imagine a minimal form of specialization that could be extracted, and that was like. But yeah, we'd have to audit it. But I think it's a plausible candidate. It could be, if it's not the current feature, it might be a subset of the current feature even.
Right. Yeah, I mean, that would be a good one to have something for. So I think that one, the restrictions are a bit more, we need more education around it also if we release it, because they're sort of, aren't there backwards compatibility issues that are really unintuitive to most people?
Right. I feel a bit, the specialization, I guess I'd like us to also have a slightly clearer picture of the next couple of steps. I'm not sure how important that is, but I guess I would like to at least talk about it a little bit, because it seemed like because I want to make sure we don't want to consider some other approach. We're happy with it. I think we probably are. In other words, there was this idea of well, we're going to allow you to have kind of where clauses and choose between impls based on where clauses, but only considering the subset of impls that meet the specialization criteria. And I feel like we never fully talked about that path and made sure we're happy heading down it. I think the minimum form of specialization would probably be one that's based on types and not where clauses. Kind of saying, if you write an impl for a specific type, it can override a generic impl. That's the first minimal slice. And maybe that's okay all by itself, but before we go much down the where clause route, I'd like to at least be sure that we have talked out where we think we're going. It might need some different syntax or something.
Yeah, I think that sounds right, because,
Anyway, all right, thanks everybody.
One thing I've just recalled that would be worth looking over before we think about stabilizing is the paper cut issues, because I think there are some diagnostics issues, and there's a problem where if you have types and constants of the same name, for instance, actually this isn't going to affect the MVP, but maybe another similar issue will. the implementation sometimes can't distinguish between a type and a constant with the same name, even if it's in an unambiguous position. So it'd be good just to check diagnostics to make sure that users aren't going to encounter weird issues like that.
Some of that might surface in writing tests, I guess, too. But
Yeah,
that's a really
hopefully.
good point. Like the polished criteria, how much we care. I feel like usually we should look for them, but we don't need to overly. But it is probably a case where once we do stabilize it, we're also going to want to put in some effort to
Yeah, that's true.
improving the state. Okay. And I'm going to end the meeting. Thanks, everybody. This is super productive. See you all later.